All right, let's find the composite when I don't have a value to plug in. Notice here, I just have X before we had some value to plug in for X. Now I just need to come up with these composite functions, and then we can plug in any number we want. So for f of x equals x squared and g of x equals 3x plus 1, find the following composite functions and state the domain of each. So this equals f of g of x. So what is my g of x here? My g of x is 3x plus 1. And so now for my function f, where I see x, which happens to just be 1, I'm replacing this 1x with 3x plus 1. So this becomes 3x plus 1 squared. Okay, so I rewrote this as f of g of x. I figured out what is my g of x. Well, my g of x is told to me right here. It's 3x plus 1. So I replace g of x with 3x plus 1. And then here, this is my function of, or this is f of 3x plus 1. So now I take my function, and where I see an x, I replace it with 3x plus 1. Here, we make common mistakes here, and for lack of better words, we distribute that square to both terms. You cannot do this. If I expand this out, this is 3x plus 1 times 3x plus 1. When you FOIL, you will get 9x squared plus 6x plus 1. Okay, let's do this again. And just like before, don't assume that these are the same, because more times than not, they are not the same. So this is g of f of x. So what does my f of x equal? Well, my f of x is x squared. And now take your g of x, and everywhere you see an x, which is just this 1, replace it with x squared. So this is 3 times x squared plus 1. The only thing I can really do is just multiply this and get rid of the parentheses. So this is 3x squared plus 1. Again, not the same. Here we have f of x. So what is my f of x? My f of x is x squared. And now f of x squared, take your function f, and everywhere you see an x, replace it with x squared. This becomes x squared and then squared. Because you are taking this x right here and replacing it with x squared. So that squared on the outside is still there. And so this is x to the 4th. And then lastly, this is g of x. Well, what is my g of x? My g of x is 3x plus 1. And now take your g of x, and everywhere I see an x, I'm replacing it with 3x plus 1. So this becomes 3. I'm replacing this x now with this right here, 3x plus 1. And then I'm still left with a plus 1. Distribute your 3. You get 9x plus 3 plus 1 from the outside here. And then you can combine your like terms. So we get 9x plus 4. Now, not only do my instructions tell me to find the following composite functions, but also need to state the domain. So remember, there's only two things that can make your domain something other than all real numbers. And that is if you have a radical, I do not. And if you have a rational function, you cannot divide by 0. Well, these are all polynomials, not rational functions. And so therefore, my domain is all real numbers, or negative infinity to infinity. If you have no fraction, you can't divide by 0. If you have no square root, you don't have to worry about taking a square root of a negative number. Okay, here's another example. For f of x plus 1 and g of x equals the square root of x, find the following composite functions and state the domain of each. So this is f of g of x. My g of x is the square root of x. And so now for my function right here, my f function, everywhere I see an x, I'm replacing this x with the square root of x. So this is 5 times the square root of x plus 1. The only thing I can do here, and I'm going to actually bring this down instead of over, is 5 times the square root of x is just 5 square root x plus 1. Okay, so that's what my fog of x equals. So now the domain, I don't have to worry about dividing by 0, but I do have to worry about the square root. So whatever's under the radical, in this case just x, you have to set greater than or equal to 0. Well, there's no solving there, so that is your domain. And that should kind of make sense. If you put in 0, 1, 2, 3, 4, anything above that, you're going to get a positive number. If you do anything below, -1, -2, -3, so on, you're going to get imaginary numbers there. Let's do the opposite, which should not be the same. More times than not, it is not. Okay, so I have g of f of x. Well, what is my f of x? My f of x is 5x plus 1. So now take your g, which is square root x, and we are c in x. I'm replacing it with 5x plus 1. So this is the square root of 5x plus 1. So my domain, I have to make sure that what's under the radical, which is 5x plus 1, is greater than or equal to 0. So this one we have to do a little bit of solving. We'll subtract our 1 over and then divide by 5. So x must be greater than or equal to -1/5. Anything less than that, then this becomes negative. One more example here, example 6. For our function 3x minus 4 and 1/3 x plus 4, find your composite functions and state the domain. So this is f of g of x. My g of x is 1/3 x plus 4. So now take your function here, and where you see an x, replace it with 1/3 x plus 4. So we'll have 3 times 1/3 x plus 4, and then minus 4 on the end of that. these are being multiplied together. So 3 times 1/3 or 3 divided by 3 is 1. Those cancel. So I am left with x plus 4 minus 4. Or 4 minus 4 also cancel, it becomes 0. And so then this is 0. Sorry, that's not 0. That's x. My domain, if you have x, there's no limit as to what I can plug into x. This is all real numbers, negative infinity to infinity. Okay, g of f of x equals g of, well, what's my f of x? My f of x is 3x minus 4. So take your g of x and everywhere you see an x right here, replace it with 3x minus 4. So we have 1/3, and I'm gonna put this in brackets. No, I'm not. Yes, I am. Okay. Times x, 3x, excuse me, 3x minus 4. And then plus 4, like so. I really don't need these parentheses here, but I like whenever I substitute in something for x to put in parentheses. It just is a good habit to be in, but I really don't need those. So this is 1/3, 3x minus 4 plus 4. Your 4's cancel. So I'm left with 1/3 times 3x. Again, 1/3 times x, or 3 divided by 3 is 1. Those cancel, and I'm left with x again. I said that these hardly ever are the same thing, right? They are this time. And when they are, this is a special circumstance. These are considered inverse functions. Okay, this is just a little tidbit. This is what your next lesson is over. Okay, so hint here. When you have composite functions and they happen to be the same thing, this is a special circumstance where we get inverse functions, which is what next lesson is all about. But just like up here, if we get x, then my domain is all real numbers because I have no limit as to what I can plug in there to x.